Check out how high these different balls bounce. The basketball, the super bouncy ball, and the golf ball. Now I'm gonna try the golf ball on top of the bouncy ball on top of the basketball. And then I'm gonna explain how it's related to a supernova. Did you see that? Probably not. So here it is again. The golf ball bounced to 28 feet. We dropped it from about 3.5 feet, so it went up 800% of its dropped height. In fact, if you consider that by itself, the golf ball bounces about 70% of its dropped height, it went as high as if it had fallen from 40 feet up. That is awesome. So how can we get the golf ball to bounce up with that much energy? Let's simplify it to these two balls. When you drop them individually, each ball starts out with some potential energy from the height of the drop. As the balls hit the ground, some energy goes into heating up the ground and some goes into heating the ball. Because that energy left the ball system, you can't get back up to the same height. But when you combine them, the tennis ball goes higher than its dropped height. Way higher. Where does it get the extra energy? As the basketball bounces, it compresses, storing elastic potential energy. As it releases, it springboards the tennis ball upward just at the right moment. This is like the double bounce on a trampoline when you jump right before someone else. You prepare the elastic of the trampoline by stretching it and storing energy, which can then bounce the jumper even higher. In the same way, the basketball stores energy in its compression and is able to push the tennis ball. But just like the double bounce preparer, the basketball can't go as high. You can see that here. It bounces even less when 3 balls are dropped together. Also, during that transfer of energy, some momentum transfers from the basketball to the tennis ball. And since the basketball starts with way more momentum because of its larger mass, the tennis ball's velocity increases by a lot, and it flies up, up, and away. Now back to the triple super ball bounce. Now you get the energy from the basketball's bounce being transferred into the bounce of the super bouncy ball, which is then transferred to the golf ball's bounce. You put the same amount of energy or momentum from 2 more massive objects into a smaller object, and it will go much faster. Epic! Just like the explosions of a supernova, which may seem unrelated, but what we just did is analogous to the process that occurs during the explosion of a supernova. Just like our more massive basketball transfers momentum to the smaller balls, energy from the dense core of the supernova is transferred in a shock wave that moves through the star to the less dense layers and accelerates them outward at a super high velocity. More massive or denser layers in the core of the supernova begin to collapse when fusion stops there. The collapse is halted when the neutrons in the core actually touch, sort of. This causes the implosion to rebound and bounce outward. You end up with a dense core left behind and these wild outer shells of star exploding outward. Pretty cool. And of course, if you try this at home, which you should, you have to make sure the balls are perfectly vertically aligned because any off-centeredness gets amplified by the 2 points of contact, which is why we sadly couldn't get the quadruple tower of balls to work. But if you put a little ring of hot glue or something similar on the balls, it helps to balance them. Happy physicsing!